Okay, Physics 20, we're going to continue where we left off in our notes around page 14 from our notes, and I'll just go through them. So we did this lab when we finished up before we had to leave. And so we talked about systems involving two objects connected by cords and pulleys can be analyzed using Newton's second law. It's important to identify the total mass that is accelerated and use the equivalent dynamic system, in which often the equation F net equals mass times the acceleration is used as a scalar equation. Okay, so again, scalar meaning we don't have to worry about like this one's pulling down, this one's pulling over. We're just going to get the overall kind of F net. Okay, so example, so a mass of 1.5 kilograms is connected by a cord, okay, and a pulley to a cart on a horizontal tabletop as shown in the sketch. So exactly what we did with our pulley cart lab that we did before the break. Okay, the cart has a mass of 3.5 kilograms. The system has negligible friction, so we don't have to worry about friction. Okay, find the acceleration of the system if the cart is released from rest. So cord and pulley transfer the weight of the mass to the cart, and the force that acts on the cart as a result is horizontal, directed to the right. As shown at the right, a free body diagram. So we have our free body diagram here. Okay. For the diagram shows equivalent systems with the force from the cord and the mass as a horizontal force. So this is the force coming from the mass that's pulling down. The vertical force is Fg, and F normal have a vertical sum of 0. So again, like that's along the table, the Fg, the table is pushing up with the same force as the weight. The cart's not falling through, so they're equal. Okay, the applied force is the weight of the 1.5 kilogram mass, okay, and the cart's mass that are accelerated. So the mass value for the second law of the equation is our total mass. So we're going to get 5 kilograms, not just the mass of the cart, not just the mass being pulled down. Okay, so to find the weight of, but we do have to find the weight, okay, or F, like the force of this mass pulling down. Okay, this is the weight we're looking for. Again, so we can do that by times in our 1.5 kilograms because that's the only mass that's being pulled down, times our acceleration due to gravity, and we got 14.72. Continuing this problem up here, once we have like our total net force, the only force acting on it is this force that's of our weight that's pulling down. So that's the sum of all of our forces. Here we want to divide that by our total mass, so the 5 kilograms. Again, we got our acceleration, 2.94 meters per second squared. Okay, one thing to note that both the weight formula and the second law are using as scalar equations. The direction and signs would cause confusion for this question. You end up with, like if you put a negative for 9.81, but the cart's going this way, and so that's why it's easier to just use the scalar equations in this case. Okay, so let's do a couple of examples of these types of questions. Okay, so find the acceleration. In the preceding example, if the mass of the cart is 2.5 kilograms, the suspended mass is 1 kilogram, and the force of friction is 5 newtons acting horizontally to oppose the cart's motion. Okay, so again, we need to know, we're going to pull out our different weights, and to find the weight, again, this is what's happening if we have our free body diagram. Okay, our force applied, this is going to equal our F force due to gravity or our weight. Okay, but now we have a force of friction pulling back on it. Okay, and so we can solve from there. So we can start Fg is equal to our 1 kilogram mass. That's what's being pulled down, so times 9.81 meters per second squared. And we got 9.81 newtons is our Fg. Okay, we need to find, okay, like what we did here, we need the sum of all of our forces. Okay, so our sum of our forces, okay, is going to be our Fg, so 9.81 newtons, minus our force due to friction, because that's going in the opposite direction. So we got our sum of our forces is equal to 4.81. 4.81 newtons. And now using the same formula we used up here, the acceleration equals the sum of all of our forces divided by our mass. This is our total mass, so it's going to be the 2.5 plus the 1 kilogram. So our acceleration 4.81 newtons divided by our total mass 3.50 kilograms, and our acceleration is 1.37 meters per second squared, okay, which is correct. Okay, the sketch to the right shows an Atwood machine, which are two masses suspended from the ends of a cord that passes over a pulley. Okay, if mass 1 is 2.3 kilograms, so this mass 2.30 kilograms. Okay, mass 2 is 1.7 kilograms. Okay, find the acceleration of mass 1 if friction is negligible, so friction would be within the pulley. Okay, we aren't worried about that. Be sure to give the direction of the acceleration. All right, so first off, we have to find, so if we think of what forces are pulling, this has a force pulling down this way. So that's Fg for mass 2, and then we have a Fg for mass 1. So we'll find those two forces due to gravity or their weights. So 2.30 kilograms times 9.81 meters per second squared. Just going to solve these, and I'm just trying to make the video shorter, so I solve for these. Okay, we need our mass total. So we're going to add up both weights. So 2.3 kilograms plus 1.7 kilograms. We got a total of 4 kilograms. Okay, and so one of these is going to pull down, one of these is going to be pulled down with it. And it makes sense that the one with the higher mass is going to pull down. So in order to solve, okay, for the speed at which, or the acceleration that's going to be pulled down, okay, we need our sum of our forces again. Okay, so we have our 22.563 newtons. Okay, and then we're going to subtract this. We're going to make this one negative because it's pulling against the force of this one pulling down. So negative 16.677 newtons. So our sum of our forces, we get 5.886 newtons. Now we're just using the same formula. So acceleration equals the sum of our forces over our total mass. So we got, our 5.886 divided by 4 kilograms. And we got our acceleration is equal to 1.47 meters per second squared. So that's our answer. And then it asks us, give the direction. Well, our larger mass is going to be what's pulling down. So that's where it says here, mass 1 is going to fall, mass 2 is going to be coming up. All right. Let me know if there's any questions. Feel free to email me. I'm going to post the next video pretty quick here, and you'll be given, I'll go through most of the questions on our note pages, and then you'll have assignments will be based on a couple questions that we based on the same material.